Hi everybody, Johnny here. I hope you're doing great today. You can find more good math at jmathpage.com. Today we're looking at multiplying 9's. But we're going to think about 9's through scaling. Scaling is an interesting way to think about multiplication because it has to do with things growing and shrinking. So let's start down here. I want to make something to measure. So I want to make something that is just 1 unit tall. And this will be my measurement. I'm going to start everything from here. This is 1 measure tall. You can see how there can be other measures, right? But what if I wanted to make this twice as tall? What would I have to do? Well, let's do that. If I want to make it twice as tall, I'll start with a base, and I'll go up 1 measure, so it's the same now, and then I'll go up 1 more measure. Now it's twice as tall as the original. This is 2 times the measure of the first one, and this one is only 1 times itself. All right. So from here, let's keep growing. What if I want to make a line that's 3 times as much as the first measure? Let's start with a base. Let's climb up. Ready? 1, 2, 3 measures tall. So this one is 3 times the measure of the first one. All right. And the next, start with a base, climbing up 1 measure, 2 measures, 3 measures, 4 times the measure. That's how tall this one is now. So this is 4 times 1, 2, 3, 4, the measure of the first one, which is only 1. The next one, start with a base, let's climb up. 1, 2, 3, 4, 5 measures tall. So this one is 5 times as much. 1, 2, 3, 4, 5 measures. Only 1 here. So this one is 5 times as much. The next one, starting here, climbing up 1, 2, 3, 4, 5, 6 measures tall. This one is 6 times as much. 1, 2, 3, 4, 5, 6 measures tall, whereas this is only 1 measure tall. It's so much more than the first one. The next one, set ourselves a base, let's climb up. This is the same as the first measure. This is 2 times, 3 times, 4 times, 5 times, 6 times, and this last one is 7 times the measure. 7 times the measure, 7 times the measure of our original one. The next one, across, let's climb up 1 times the measure, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times the measure. 8 times the measure of the original. 8 times the measure. It's so much taller, isn't it, than this first one. Let's do 1 more. This one will have to be the tallest of all, right? Set our base 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times the measure of our original. So 9 times as tall. Look how tall this one is. 9 times as tall as this first one. So that's what scaling is about. Things growing, but it also could be about things getting smaller too, or shrinking. So you could go from 9 to 8 to 7 to 6 to 5 to 4 to 3 to 1 to 2 to 1. And you could be shrinking as much as you are growing. Scaling works in both directions. So what does this have to do with multiplying 9's? Let's try something out here. So I'm going to put a stack of 9 boxes here. So here are 9 boxes. I'm going to stack them right here. And if we look at it, you can see we have 9 boxes here. We have 1 stack of 9 boxes. This is how high it is. If we stacked one stack of 9 boxes, it would be this tall. How many boxes do we have altogether? Just 9. Now what if we want a stack that's twice as big as this one stack of 9 boxes? What if we wanted twice the height? What if we wanted it to be twice as tall? Well, we have our one stack here. Well, I think we're going to have to do something special here. So let's try it out. I'm going to start with my one stack of 9 boxes. But in order to make it twice as tall, I'm going to need another stack, right? So now I have 2 stacks of 9 boxes. Okay. So how many boxes are there altogether? 2 stacks of 9 boxes? Well, I have 9 and 9 more. That gives me 18. Okay. So we started with one stack of 9. What if we want it to be 3 times as tall? Let's put them out. Let's start with one stack of 9 boxes, another stack of 9 boxes, and a third stack of 9 boxes. Okay, so 3 stacks of 9 boxes. How many boxes in all? Let's count them. We have 9, and 9 more make 18, and 9 more again gives us 27. Now 3 stacks of 9 boxes gives us 27 boxes altogether, which is 3 times as many boxes as our first measure. One stack of 9 boxes only gave us 9, so you can see how it's growing. What about 4 stacks of 9 boxes? Well, here we go. 1 stack, 2 stacks, 3 stacks, 4 stacks of 9 boxes. How many boxes altogether? Well, 9 and 9 are 18. 18 and 9 more, 27. 27 and 9 more give us 36. So 4 stacks of 9 boxes, 36 boxes altogether, which is 4 times as many as our first stack. Okay, what about 5 stacks of 9 boxes? 1 stack of 9 boxes, 2, 3, 4, 5 stacks of 9 boxes. How many boxes altogether? 9, 18, 27, 36, and 9 more give us 45. So 5 stacks of 9 boxes give us 45 boxes altogether, which is 5 times as many as we started with. All right. 6 stacks of 9 boxes. 1, 2, 3, 4, 5, 6 stacks of 9 boxes. All right, how many altogether? Well, we have 9, and 9 make 18, 9 more 27, 9 more 36, 9 more 45, and 9 more give us 54 boxes altogether. Okay, so 6 stacks of 9 boxes is 54, which is 6 times as many boxes as what we started with. So we see how it's grown. What about 7? 7 stacks of 9 boxes. 1, 2, 3, 4, 5, 6, 7 stacks of 9 boxes. How many boxes is that altogether? Well, we have 9, 18, 27, 36, 45, 54, 54 and 9 more take us to 63. So 7 stacks of 9 boxes gives us 63, which is 7 times as many as our first set of 1 stack of 9 boxes. So it's grown and grown and grown. What about 8? All right. 1 stack, 2 stacks, 3 stacks, 4 stacks, 5 stacks, 6 stacks, 7 stacks, 8 stacks of 9 boxes. How many altogether? Well, let's count. 9, 18, 27, 36, 45, 54, 63, and 7 more, 63 and 7 more. I'm sorry, 63 and 9 more take us to 72. So that's a lot of boxes. I almost lost count. So 8 stacks of 9 boxes take us to 72, which is 8 times as many boxes as our first stack of 9 boxes, right? Last one. Hopefully they won't fall over this time. Are we ready? 1 stack of 9 boxes. 2, 3, 4, 5, 6, 7, 8, 9 stacks of 9 boxes. So 9 stacks of 9 boxes. So many there. Look at how many there are. So how many are there altogether? Well, let's count them. 9, 18, 27, 36, 45, 54, 63, 72, 72, and 9 more give us 81. So 9 stacks of 9 boxes give us 81 boxes altogether, which is 9 times as many as our first one, which is just 1 stack of 9 boxes, only gave us 9. So we can see how things grew and grew and grew. Let's think about that for a moment. So let's start here again at our beginning. First we had just one measure, and then we decided it should be 9 boxes tall. And then we grew it. We doubled its size, tripled its size, quadrupled the size, made the size 5 times bigger, 6 times bigger, 7 times bigger, 8 times bigger, 9 times bigger. Look how tall this last one is compared to that first one. So we can think about scaling as things growing. We can also do some interesting things with this. So what if we start at 3 stacks of 9 boxes? All right, and we said that was 27, right? What if we want to take just this stack, 3 stacks of 9 boxes, and we want this one to be twice as tall? Well, look what happens. If we make this twice as tall, it has to be the 6, right? So 3 stacks of 9 boxes doubled is the same as 6 stacks of 9 boxes. So that's another way of looking at growing. Now scaling can be about growing, but it also can be about shrinking, right? Getting smaller. What if we do the opposite? What if we start with 6 stacks of 9 boxes and we say we only want it to be half as tall? So this is how tall 6 stacks of 9 boxes is, right? 6 stacks of 9 boxes. Halfway would be like here, right? So which measure is only half as tall as this? Well, if we go across, we see that if we shrink it in half, we see that we have 3 stacks of 9 boxes. So this is half as much. So if we started with 6 stacks of 9 boxes and we said we only want half of it, if we wanted to shrink, we would have 3 stacks of 9 boxes. So scaling helps us think about multiplication in more than one direction. And it's a very useful idea in understanding multiplication. I do hope this has been helpful to you.